of QCRETE, and today's number is 71. So first of all, I would like to thank and congratulate the entire team of QCRETE for offering this education platform to the engineering fraternity. And at the same time, today we have a special guest, the speaker, Mr. Ashish Singhai. Thank you so much, sir, for joining. And also, I'm very happy that our VP South, Nagendra sir, has also joined. Sir, Nagendra sir, welcome. And I could see many of members across the country from various centers of ICI joining this platform. And at the same time, I welcome each and every one, the participants of this particular program, and would like to thank you for taking out your precious evening time in upgrading ourselves to the present trend. So without wasting much time, I once again welcome each and everyone, whoever is present in this forum, and hand over the proceedings to the Director Technical, QCRETE Readymix India Private Limited, that is our Kaushika sir. Sir, over to you.
Good evening. Good evening to all the participants of today's enlightening webinar. Thank you, Anil Baliga sir. And thanks to all the, I can say, dignitaries like Sunit Gupta, Dr. Nagendra, and many other people, Nirmalendra Kar Gupta, many people are there who have come and joined this webinar. We are thankful to all of them. I'll just introduce shortly. The list is very big, and Mr. Ashish Singhai has very big achievements to his credit. I will make it short because the time is already 7:12.
Yes, sir.
Dr. Ashish Singhai, he has done BE in Civil Engineering. He has got a PG course done in Marketing Management. He has got doctorate in sustainable innovations in concrete technology and net zero carbon emissions, which is, I can say, the sought after areas at the present moment. Presently, he is national head for KJS Cement, and he has been in many roles. He has been a leader, business development, strategic leadership, new product development strategies, channel. Now he's a combination, one in all in one. I can say both technical as well as I can say business management, and most importantly, he has excelled all through his career for the love and passion to educate people, bring awareness among his customers and students. He has visited many places across India, like IIT Indore, IIM Indore, Indian Constitution Institute, Bangalore, Gwalior, many places across India, as I said, to educate people on different subjects in cement, concrete technology. Not only cement and concrete technology, the list is very big. He has also been equally enthusiastic in teaching people on the other aspect of business, like customer relationship management, impactful presentations, how to keep the audience engaged, which is very important in the today's world, actually. Conflict management. So he has a big list of lectures and areas of excellence, I can say. And he has been also involved in innovations in construction materials, high performance concrete. You name it, he has it under his belt, I can say. Especially looking at this CV, I can again say very impressive and very big achievement in his career, touching all the areas, including giving lectures in places like Institution of Values, passionate for last 34 years. Trained in groups of many, more than 1,800 engineers, architects, around 4,000, big numbers in the field of concrete technology and allied fields. So with this background, thank you, Mr. Ashish Singhai, for accepting to come on our platform and this important subject. Thank you.
Extremely privileged, Kaushik sir, for your wonderful introduction of mine, and I really feel short of words to express my thanks and gratitude to Indian Concrete Institute Mangalore chapter. At the same time, QCRETE Readymix Concrete, which has been instrumental in just making such a vast awareness amongst the technocrats, students, and engineers fraternity at a very, very large scale. And as I was just listening, that this is the 71st session, which is quite a big number actually. And that reinforces the vision of the management of QCRETE Concrete, and at the same time, Indian Concrete Institute of Mangalore chapter, which is doing this bit. So I really appreciate the words, and I'm extremely privileged to be to be invited in this particular session to deliver my words and whatever technical knowledge I have. So thank you very much of all the participants, and I just start my presentation, which is basically on the very latest cement, to say so, in the context of our Indian cement industry, which might have got a little more in attraction and attention across the globe. But in Indian context, it has recently sprung up, and at least 2 of the cement companies have already taken the initiative to manufacture it commercially, the JK Lakshmi Cement and JK Cement. And I am pretty much sure that more number of commercial manufacturers in the cement domain will pitch into it and realize the importance of this particular cement, which is largely a green cement. So I just switched on to this presentation. Yeah. Just a second. Right.
Sir, your screen is visual, sir. You can just present your presentation. You can click on it.
But just a second. Okay, fine. So now is it visible now?
Yes, sir.
Okay, fine. Okay, that's it. So I'm just making it on a larger this thing. So now is it visible, sir?
Yes, sir. Perfect.
Okay,
perfect.
Fine. Yeah. So So once again, welcome all the participants and in Indian Concrete Institute Mangalore chapter. At the same time, QCRETE Readymix Concrete Management. So this particular topic which I have selected for the evening is LC3 Cement, which is the innovations for decarbonization. As we have just discussed a little bit on that our industry is fast migrating to new innovations, new ideas, and just as we know that the Indian construction industry is booming in a very, very big way. Almost every small town has become a big town, and big town is becoming a mega town. So that is how the growth of Indian construction industry is taking place. So when the construction industry grows, when the infrastructure industry grows, there is a lot of potential, and a lot of, concerns also at the same time, how to mitigate the carbon dioxide emission effect. Because as we all know that any construction requires cement and steel, and these are the two major items which emanates the maximum amount of carbon dioxide emissions in the atmosphere. As almost as per the calculation, 8% of the total global carbon dioxide emission is contributed by these two industries alone. So that requires a lot of attention, lot of research, and a lot of technical know-how, how to reduce, how to mitigate this carbon dioxide emission. Now, with the advancement in technology, earlier it was only OPC cement was being used by our Indian cement construction industry, but now it has been gradually replaced with blended cements. So because of which, Portland Pozzolana cement and Portland slag cement, and now very recently, and about 10 years ago, we have introduced, the cement industry has introduced triple blend cement, wherein fly ash and slag both can be added as per the norms designed and set by the Bureau of Indian Standards. So now we have got very good options available, but still, as we know that we not only have to think about the strengths, now the industry is fast migrating towards durability, and not only durability, it has to be coupled with the sustainability also. So now, earlier days, it was only strength was the only parameter. It has fast switched towards durability, and now we are talking about durability, strength coupled with sustainability. When we talk about the sustainability, it has to have the conservation and preservation of our basic raw materials, basic resources, which are anyway will die down one fine day. So how to prolong the life, how to make the conservation of all those raw materials, whether it is coal, whether it is limestone, or whether it is any iron ore or any ore material which is mined from the mother earth, it has to have a and better alternate that can conserve these materials for many centuries. So that is how the sustainability objective has come into the picture, and which is why the entire globe is now talking about net zero carbon emission. So these are the things which are coupled with each other in one way or the other, closely linked. Sustainability is linked with conservation of the raw materials, and at the same time we have to ensure that our earth, mother earth, doesn't have warming more than our limiting factors as a human being. So the emission has to be curtailed down. Now let us talk about the brighter side of our construction industry. As Indian construction industry is absolutely on fire, we have been watching, witnessing a lot of skyscrapers, huge infrastructure projects coming across, whether it is railways, whether it is dam projects, whether it is smart cities, Bharatmala. So many projects are simultaneously happening, and which is making this demand of construction in a much huger way as we have never witnessed in our past. So Indian construction industry is now growing at the rate of almost 6.2% CAGR, and it is scheduled to hit almost 1.4 trillion. That is almost 10 amounts to 1.4 lakh CR by 2028. That is almost 2 years down the line. Government's outlay of over 111 lakh crore is allocated under the National Infrastructure Pipeline, which is NIP till 25, which is already a year gone by. It has been further revised. Okay. Now, what are the major drivers for this infrastructural growth? As we know, PM Gati Shakti, smart cities, more than 100 cities have been identified. Bharatmala, which has almost 65,000 kilometers of highways, almost 35% has already been constructed, but balance is still more, and government has recently announced further more addition of these number of kilometers. So these are a couple of very green shoots in the Indian infrastructure industry, which is compelling the Indian cement manufacturers, steel manufacturers, construction industry, structural designers, and the overall that ecosystem of construction industry to think very seriously on the impact of this humongous construction which is happening. So LC3, which is the very latest introduction in our construction industry, so we have to give a very serious thought on that, and it is very much supporting the sustainable objective. Now, when we talk of sustainable development, what does that mean? Sustainable development meets the need of the present without compromising the ability of future generations to meet their own needs. So you continue to construct you continue to build infrastructure, buildings, whatnot, but ensure that the future generations, maybe 20 years, 50 years, 100 years, 150 years down the line generations will also have some material left for even further constructions. So this is how sustainable development is all about. And sustainability is definitely always local. You need to learn. You need to devise the technologies where the local materials can be used to the maximum instead of importing the designs, technologies, products or materials. Local material is always sustainable. So this sustainability dimension is, standing on three large pillars: environment, society, and economy. So what is environment? So conservation of the resources, protection of the environmental, and biodiversity preservation. What is societal sustainability? Energy and food security of the humans, health services and security, and social equity, equanimity, what we call it. And third one is economy. Means any construction has to have a very broader focus on economy. So there has to be cost efficiency, profitability and growth, and third one is valuation of the services. So these are the three broader pillars upon which the sustainability is based. Now, how to go about that? The sustainable development improves the quality of life, protection of the environment, energy conservation, waste reduction and recycling, efficient use of natural resources, as we just discussed, and better operational performances. That means using new techniques to improve durability, cost, time, efficiency, better productivity. So in the last option, we can say that our LC3, that is Limestone Calcined Clay Cement, comes into picture. And this is not alone. Apart from that, in the very recent researches, geopolymer concrete has also sprung up, and so many, broader based research are already going on. So that can also be possibly a very big alternate for traditional ordinary Portland cement. Yeah. So how does it help in sustainable buildings? As we say, more and more use of green materials, optimizing the demand for electricity, water, and natural resources, generate electricity, and partially replace with renewable means. Like, let us go instead of typical artificial lighting, coal-based thermal lighting. Let's go for solar, hydel, or wind power. Catering to the water demands through sustainable processes such as rainwater harvesting. So treating and recycling the wastewater and making it to bringing it to use for the humans. So recycling and reuse of waste on the site, ensuring that all the waste material is managed on the site itself. No more additional material to be called at the sites, and it generates optimum waste processed locally, like household waste, segregation, and disposal. And as this is another new theme has already sprung up in last couple of years, construction and demolition waste management. So not only we have to reduce the waste material, but even if it happens to be waste because of demolition of any structure which might not be no longer habitable, or possibly any new infrastructure is coming up, so we need to demolish a couple of structures, or possibly any infrastructure which by virtue of some reasons has to be demolished, the entire demolished material can be put to recycling, and some useful sand, aggregates, and material can be extracted and can be used for other purposes in the construction industry. So what is the thermal impact of the industry? As we discussed, that our construction industry, which we all are part of, is almost contributing to 35 to 40% of the this impact of carbon emission. So the global carbon emission is contributed almost to the extent of more than 1/3 by our own construction industry, almost 30% by the manufacturing industries, and transport industries again almost 1/3, and almost miscellaneous is 10%. So, but the maximum out of all the industries is our own construction industry. So we have to have a very, very strong focus on how to mitigate this threatening and alarming consumption of alarming carbon dioxide emission. Sustainability impact we have already discussed in a little bit I just skip this particular. No, this is something that I need to put a focus on. That is embodied energies of the building material. What is embodied energy? Why I'm saying all these things? Because that will reinforce the relevance of LC3 cement. So before that, we need to understand what is EBE, that is embodied energy of building materials. Every single material which we use carries certain amount of EBE in terms of its energy that it has consumed. So which are the different dimensions where a product consumes the energy? First is EBE, that is embodied energy, is the amount of energy required in manufacturing a particular product, from mining or extraction of the natural resources to manufacturing process to transportation and finally the product delivery. So put together all the energy consumed makes EBE of that particular product. So energy is embedded in the materials. So now this energy required in making a product, the more embodied energy it values is the more is the carbon footprint it generates or emanates in the atmosphere. So ideally, any material which has low EBE is good for us, for green buildings, for sustainable construction, etc., etc. And at the same time, if the EBE component is more, then we need to think about that and we need to devise an alternate of that particular high EBE product. So embodied energy does not include the operation and disposal of the building material, but it carries the total quantum of energy that has gone into making it. This is how we define EBE. Now, cement and steel, just look at that particular slide. And cement has almost 6.7 megajoules per kg. Cement. Steel is almost 5 times of that, 32 megajoules per kg. So what we use in our construction industry as a reinforcement steel bars has 32 megajoules per kg of EBE, which is phenomenally high. At the same time, acrylic paints 61, aluminum is even higher than that. Plastic is even almost 90 megajoules per kg. So these are all high EBE products. At the same time, just compare it with fired clay brick 1.64 and just look at the double AC block, that is aerated autoclave concrete blocks. It has only 0.6. So when we have to compare between a fired clay brick and double AC block, obviously we'll go for double AC blocks considering its low EBE composition. Or at the same time, if we go for high fly ash volume blocks, it is almost 0.56, so almost equivalent to double AC block. So that is a broad comparison as to if we are given a choice which particular cement or which particular steel or which particular block need to be used basis on the EBE it has. Now, so we cannot skip cement, we cannot skip steel. It has to be there, but there has to be judicious selection and judicious structure designing wherein we can minimize the consumption of cement, we can reduce the steel requirements, or possibly it can be replaced with some, befitting options or alternates. Just a broader look, the production of 1 cubic meter of concrete, which is almost densities 2.5 tons, requires almost 2775 megajoules of energy. Okay, cement has 6.7, steel has 32, fired clay is 1.64, double AC block is 0.6. So these are the figures which very clearly, indicate that EB plays a very major role, and that determines how much carbon dioxide emission is, emanated in the atmosphere because of using these materials. This is a global vision of decarbonization of the globe. So the net zero carbon mission is almost 2050, by which the entire globe is committed to ensure that climatic changes are arrested and the carbon dioxide emission is brought to almost zero, or what we call it net zero. Means the quantum of carbon dioxide that we are emitting versus the quantum of carbon dioxide that we are consuming and converting it to some meaningful applications. So the net zero has to be there by 2050. This is the global objective. Yeah, now this slide says it all. Sustainable solutions in construction, use of smart green innovative cement and concrete. Most innovative and scientifically designed cement and concrete. I start with blended cement. As we all know that by the addition of fly ash and GGBS or possibly triple blending, we can reduce CO2 emissions significantly, and that supports the sustainability objective. The one which is the topic of the day is LC3, that is limestone calcined clay cement. I will elaborate in the subsequent slides. And we have got translucent concrete, which consumes less artificial light. Pollution eating cement or concrete, which is prevalent in some advanced countries, not in India. So that reduces the pollutants. AAC block, we all know, it is a 100% genuine green building product. M sand, that is manufactured sand, or extensively used across South India, some parts of Western India, and some parts of Central India also. So that is helping us in conservation of the rivers and greenery. So our rivers, which were earlier dying, possibly we can increase the lives of such rivers. Pervious concrete, as we know, it will sustain and support our objective of rainwater recharging, and geopolymer concrete. So these are the major innovative initiatives have been taken in the last couple of years. Today's topic is LC3, so we'll talk more on this today. So as we know that industry waste like fly ash, GGBS, and silica fume, metakaolin, they're all helping us in, they can be used by adding with cement and concrete, and significantly CO2 can be reduced. So as we know, every single ton of cement, produces almost 0.8 to 0.9 tons of carbon dioxide gas that goes into the environment. So that is how OPC has been totally, ignored, or possibly it has to be, rejected or at the sites, and only blended cements, LC3, or possibly geopolymer concrete has to be promoted. So that gives a broader picture. And as we know that almost 7 to 8% of the total carbon dioxide emission is contributed by the cement industry. So it is in a way a culprit to the environment. But without cement, as we all know, nothing can, no construction can take place. So we have to have a very, very focused approach on that. Slag cement has the typical ability to reduce the carbon dioxide emission by 45% as compared to OPC. In the same context, the LC3 will also help us in the reduction of the carbon dioxide emission to the extent of almost 42 to 45%. So these are the certain figures that help us in making our choice towards either blended cement or LC3, or possibly towards geopolymer concrete, which doesn't have any OPC content in as far as geopolymer concrete is concerned. So, Kaushik sir, I hope my slides are visible and my voice is quite audible.
Audible, sir. Audible.
Fine.
Yes.
Okay. Yes. So carrying on this, now let us start with the subject of the day, that is LC3. So it is basically defined as limestone calcined clay cement, and it is sustainable. It emits low carbon dioxide and practically viable solution for the cement industry. Okay, now so this is a broader outlay of this particular LC3 cement. Why LC3 has been introduced is what we are going to discuss in the subsequent slides. So what it is, how it is made of composition. First and foremost, 50% clinker is replaced. So all of us, we know that clinker is one product which is calcined to the extent of 1450 degrees Celsius temperature. That particular powdered form of limestone gets in a flowable form. It melts, it flows form, then it is being quenched rapidly. So it becomes granular form, what we call it clinkers. These clinkers are then ground to fine powder, and fly ash and gypsum powder is being added with this particular composition, and that is how we get cement. So clinkerization has been reduced to the extent of 50%. That itself says how much beneficial in terms of fuel optimization, in terms of lower clinkerization, in terms of reduction in the heat element. This is all the major benefits that LC3 encompasses. I will go in deliberately in a more elaborate manner in the later slides. Now, what are the core materials? Blended calcined clay and limestone. So blended calcined clay, that is in the raw form, and limestone in the raw form. We are not giving any temperature whatsoever. So these particular blend of clay and limestone put to fine ground powder, and then it is given some amount of temperature to give calcination, but not to the extent of clinkerization. So that is how the composition takes place. 50% is clinker, 30% is your clay, which is calcined clay, and 15%, 15% is limestone plus 5% gypsum added to as a set retarder. Okay, that is how it, this is the composition. Carbon dioxide impact is cut down by 40%. This is the beauty of LC3, and which is why it is being considered as one of the most sustainable cement, or in other words, a kind of a green cement by the global construction industry. Now, CO2 reduction is almost 40% less as compared to the ordinary Portland cement, and as we know, it can be used for all kinds of existing cement applications. Wherever any cement can be used, LC3 can be very well used and applied. So it's a kind of an eco-friendly revolution. Why it's science actually? In terms of mass housing in places like Kanpur, Nashik, or it can be even any part of southern India also, where hundreds of EWS homes go up in tight pipelines. LC3 faster setting and lower heat releases help manage deadlines and reduce cracking. So not only it's economical, but because of the 50% reduced clinker composition, the heat of hydration is also significantly reduced, and hence the cracking, and hence this product is durable. Second one is coastal infrastructure. So this is particularly meant for southern part of India. Bridges, ports, buildings near the sea face, sulfate attacks, or at the same time chloride penetrations also. LC3 cement durability makes it better suitable than even some high-grade OPCs, or for that matter, much better comparable as compared to Portland slag cement as well. Waterlogged zones in Assam, Bihar during monsoon, which we are already witnessing. Assam has witnessed one of the largest downpour in last week or so, and so is the case with Bihar and other northern part of India. So in Assam or Bihar during monsoon, water seepage is a huge challenge. LC3's dense microstructure helps resisting that better. So better interlocking of the particles of calcined clay, limestone, and that 50% clinker, so that they interground in a much better way. The particle distribution is designed in such a way that once the water is added to that particular cement, it becomes very, very cohesive and denser microstructure. So that prevents any kind of possibility of leakages and seepages. Now, what is holding it back? There are so many advantages with LC3 cement. Then why it is? What are the deterrents? What are the things which is holding it back? So, like most innovations in our industry, LC3 is still working its way into the mainstream, and some of the reasons are familiar. The first is contractors' reluctance. Let me tell you to all the listeners and viewers of the day that LC3 is a very, very recent innovation in cement industry as far as India is concerned. Okay, so obviously whenever a new product is introduced, the reluctance comes from the user community, the seller community, and the consultants also in a couple of instances. So I start with the contractor's reluctance. Let us be honest. We have all heard someone say, "Naya cement risk nahi lena." They are very much reluctant to take any kind of risk with a new cement simply because it does not have any precedence. It does not have any previous records in their domain. So they will be like shivering, or they will be possibly reluctant to experiment with a new cement. They would say, why should I take when the equal number of better options are available in the market? They wouldn't understand its technical superiority, its benefits, its sustainable objective. Possibly they will not have that kind of mindset to look into. All they know, they will simply resist any new experimentation. So this is one thing. Talking about structural approvals, some consultants still default to OPC or PPC, or for that matter slag cement, in their design specifications, not realizing LC3 has similar or sometimes better performance in many cases. I think the reason could also be contributed that it is not widespread available. Still, very few cement companies have started commercial production, so it has not caught the fancy. It has not caught the attention. It has not gone to populated structures still now. So possibly that is also which is generating a little bit of resistance from structural engineers, designers also. And availability, as we know, that very few regions have started production. So that is also one of the very concerning area. But these are growing pains. Fly ash cement faced the same kind of resistance in the early 2000s. Today it is everywhere and widespread. So the industry has seen such type of resistances, and it's then establishment of the approvals, specifications, and acceptance. So it takes time, but one fine day we'll have LC3 being available across the country, across the counters, and the structural designers will start approving it. So we are looking forward to it. Will it replace traditional cement? It's a question. Probably not overnight. LC3 is not here to wipe the slate clean. It is here to improve it. It is a new invention. It's a new introduction. It can take some time to generate that kind of awareness. Gradually, slowly, but steadily, it will take the acceptance. It will have the understanding as far as its benefits are concerned, larger benefits are concerned, and then it will start getting approved. So it will not replace the traditional cement, but yes, it will definitely create its impact, its footprint. There will always be use cases of OPC, 53 or slag or PPC for high shear concrete. But for the bulk of India's general construction needs, foundations, beams, slabs, wall panels, LC3 offer a cleaner, equally capable options, because the researchers have proved, the experiments have proved, and the kind of strength that high-grade cements have shown with LC3 is phenomenally encouraging for all of us to think and start using this LC3. So there should not be any fear. That is how the commercial manufacturers have started, in there. Yeah. In fact, for government-driven affordable housing, rural roads, panchayat buildings, even mid-rise apartments, LC3 cement could become the go-to choice. It is all the elements to become a very, very favorable choice. It just needs nudge. It just needs that nudge from the policymakers, from the manufacturers, and from engineers like us. So we all have to make a very concerted, efforts. We have to be together in promoting, in approving, and in making it applied in construction phases. And we need not to be fearful about that, because we can always approach to our cement manufacturers. They can provide you all the test certificates for cement, for the concrete that they have already experimented with. So these are a couple of very good, already backup is there, and we have to be fearless in using and applying LC3 cement. Why this matters to all of us? India is not slowing down, and it shouldn't. But as we rise, we owe it to the land beneath and the sky above to rise responsibly. LC3 gives us a way to do that quietly, efficiently, and affordably. That means we have all the reasons to be a civil engineers and to give back to the industry. So how can we give it back to the industry in a way that whatever cement I am consuming or whatever concrete I am making, let it have lower quantum of carbon dioxide being emitted in the atmosphere. So that is our social contribution by using such type of innovative cement, or possibly blended cement, or possibly geopolymer concrete. It will make stronger homes, cleaner air, and a legacy for our kids that can breathe easier in. Now, what are the basic raw materials? Just to understand the basic composition. So it consists of kaolinite, which is basically what we call it calcined clay. it is about 40 to 60%. Ideally, it is about 50%. So it is calcined at about 700 degrees Celsius to 800 degrees Celsius. Second element is limestone. As low as 65% carbonate can be used. No calcination required. So limestone, which has almost 65% calcium carbonate, it has different percentages as we mine it from different areas, but almost 65% carbonate contained limestone is to be used as an ideal raw material for LC3. It does not require any calcination. That means just mine it, ground it, convert to powder and add it. That's it. Third major element, as we say, is clinker, which is almost OPC clinker, 50% of the total quantity. And now energy. Calcination needs half the energy of the clinker production at 1450 degrees Celsius composition and production. For typical cement production, the energy or the temperature required is 1450 degrees Celsius, wherein in LC3, it is only 700 degrees Celsius. So just imagine, it is 50% energy consumption lower than typical traditional cement energy consumption. So that says it all. Typical mix would be 50% clinker, 30% calcined clay, and 15% limestone, plus 5% gypsum as a set retarder to control the setting time parameters. What is the production methodology? Intergrinding or blending, similar to OPC and PPC. So we have to simply, converting it all the three into powder form, either by intergrinding or separately bringing these powders and blending, and then ready for dispatch. What are the benefits? Softer materials considerably reduce grinding energy. As we know, since the temperature required is 50% less, these materials are very, very soft. As we know, the composition of kaolinite is basically what we call it calcined clay, is very softer material. So the grinding energy means the energy which goes to grind a material, harder the material, the more energy will go, softer the material, the less energy will go. So in this particular case, softer materials requires considerably reduced grinding energy, and which is also contributing to our energy consumption, or what we call it EBE, which I just mentioned a couple of slides back. EBE is the embodied energy which is used, which is cumulative of the used energy in all the spheres. So the softer material requires lesser amount of grinding energy. Talking about result, 40% reduced carbon dioxide emission versus OPCs. And now, what exactly is LC3 cement and how it is different from regular cement? As we have discussed, less CO2 makes it the most prominent cement among all available new option cements. Now, the need for low carbon cement, as we know, because of the 8% contribution of the cement industry in terms of CO2 is by cement industry. So suppose if we can reduce this particular component, possibly we are nurturing, or we are helping our Mother Earth to larger number of years. The cause, limestone breakdown at high temperatures. So that also requires a lot of carbon dioxide is emitted once the limestone is broken. In this case, since everything is reduced significantly, so the carbon dioxide emission will also reduce in the same proportion. What are the drivers for this low carbon cement? Rapid urbanization, as we discussed. What is the solution? Reducing highly carbon intensive clinker. In this particular case of LC3, how much is the clinker reduced? To the extent of 50% less as compared to OPC. Now, moving on to the next slide. Raw material suitability. So clay source, as we know, that kaolitic, or what we call it, calcined clay, is abundantly available. Purity level is almost low. Purity level is also good for us. 30 to 40% will do for us. It is a softer material. Reactivity test validated via standard R3 testing. Possibly, I'll discuss it in some other presentation. It is an elaborate subject. Assessment indicators, high alumina content, that is more than 18% is preferred. Global availability, strategic reserves match high demand regions, which is synergetic with LC3. So availability of raw material is pretty much abundant. No need to worry about the abundancy, but only thing is that we have to be drive and channelize our energies in accepting it material as a material that can be used for any structural construction or any kind of infrastructure projects. This is what is required. So as far as production and manufacturing is concerned, it requires only 800 degrees Celsius as compared to the clinker, which otherwise requires 1450, twice of that. Kiln methods are almost the same. That is rotary kiln or flash calciner, which is being used in today's cement industry. So no separate equipment is required. Milling options, co-grinding or separate stream milling. Again, it is an existing system in all the cement organizations. No separate machines are required. Efficiency boosters, surface additives, optimize dispersion. It can be used. Suppose if somebody wants some additional additives can be added to optimize the dispersion of the materials. Plant adaptability requires zero machinery reinvestment. That means with the existing setup, you can produce and manufacture LC3 cement. Yeah. And what is the result? Denser microstructure, improved strength and durability. As we all know, because of the three different elements, ground finely, so that the microstructure of the cement as such becomes so fine, so densely, integrated with each other, that it ultimately, talking about the concrete, strength is increased because of the better cohesion, because of the better, interlocking particles in between, and hence the durability was also improved. What are the properties of fresh concrete made with LC3? First is rheological behavior. So identical performance to the traditional OPC, PPC or PSC. It is almost the same, but admixture match. So whatever kind of compatibility test we do with other typical OPC, PPC or PSC, same kind of compatibility test with the admixtures and LC3 has to be adopted in the same manner. No other technology. Okay. Setting control, it is easily managed with simple retarders. Cohesiveness, superior anti-segregation and low bleeding due to better constituent mix. As I said, the three different materials are interground in such a manner that particle size distribution ensures that the finally produced concrete, fresh concrete, will have least amount of segregation and almost zero bleeding. So that ensures that our concrete has better packing, higher density, and hence better strengths and durability. And what are the special uses? Perfectly matches for self-compacting concrete. You know why it is suitable for self-compacting concrete? Because of this finer ingredients, because of the finer particle size distribution. So the concrete so produced with the use of some very good quality admixtures, possibly PC based, that the concrete will flow in itself and it doesn't require any kind of it will be like a self-compacting concrete. So what are the strength and structure performances? Strength matches with all kinds of structure grades. Very much useful with the existing setup. No need for any kind of additional investment is required. Optimized milling guarantees rapid hydration. Design standards follows standard strength based formulas. Key benefits: significantly lower long-term concrete creep. These are all benefits that have already been seen, and real applications, when we talk about, is proven in tunnels, viaducts, skyscrapers, reduce heat and concrete because of clinker percentage is gone down so significantly that the consequent heat is also, or what we call thermal stresses, are also very, very low. Durability, so it has a very strong resistance for chloride infusion, which is why it can protect it. It generates a very good passivation layer around your steel reinforcement. Hence, the corrosion progression is reduced significantly, and we have a longer concrete durability. Steel protection, as we say. Then very important function that we always ignore in most of the big infrastructure project is ASR, because we always test about the cement, admixtures, even steel is tested phenomenally, but the one thing which remains ignorant is ASR, that is the aggregates, that is our coarse aggregate, fine aggregates. They are not tested chemically to that extent, but these coarse and fine aggregates also have some kind of chemical infusions, and when they're integrated with the concrete for manufacturing, then obviously their impact will come into play, and we observe alkali silicate reaction in the form of prevalent cracks that appear on the surface. Sometimes they go deeper in the concrete, and possibly they can damage the reinforcement which is embedded inside. So ASR is a very, very important function which we need to pay attention more often than not. It is generally what I've observed along my career, that it is not being given that much of importance, but it has to be given. So in case of ASR suppression or ASR aversion, what we call it, through LC3, it also helps. In which way? Completely blocks reactive aggregate expansion. Aggregate also has the capacity to expand because they are chemically surrounded sometimes. It reduces the alkali sulfate reaction and hence reduces cracks on the surfaces. So that is very important thing. LC3 has that capacity, has that resilience to resist ASR generated after effects like cracks and wider deep pockets. Chemical resilience, enhanced resistance against sulfate, chloride, and carbon dioxide attack. Again, it will make your concrete a durable one. And weathering proof. So freeze-thaw performance in areas where the temperature goes to as low as -10, -15 degrees Celsius. So it is comparable to OPC and blended cements. So these are the couple of advantages. Talking about mechanical and physical properties, it has a strength which can be matched with any OPC or any blended cement. Workability, because of a very final structure, it gives a very good flowability, wonderful cohesion, good amount of packing, and it prevents segregation and bleeding also. Talking about economic viability, possibly people might think that production of LC3 requires a huge amount of capex, but as such, it doesn't. So considerably lower than new clinker lines. So the capex saving we already have. OPEX, lower fuel requirements save up to 750 rupees per ton. As we say, as we have studied in the previous slides, that in terms of traditional cement, the temperature required to calcination of the typical limestone powder is 1450 degrees Celsius. Whereas in the case of LC3, that particular calcined clay requires only 700 to 800 degrees Celsius, which is almost 50% of the temperature required. So the lower temperature requirement, that means lower fuel requirement. So that also saves to the extent of 750 rupees a ton. So if suppose LC3 is manufactured by some company, so obviously the OPEX advantage is very much prevalent, and that makes cement very, very economical as well. National saving, how come? Lower clinker content has reduced precious coal consumption. So we are saving a coal consumption to significantly higher proportions because of the lower temperature required. Carbon pricing saves almost 25 euro per ton under tax frameworks. So the tax framework which is applicable in other countries is equally applicable in our Indian context also. Market pricing, commercially sold at current OPC prices possibly, but as the production is scaled up, its pricing can also be commercially it can be made more viable for the consumers. End user value, it decreases future structural maintenance and repair costs, etc., and labor component. If the cement is generating a huge amount of heat of hydration, possibly cracks will appear more often than not, and later on the end user has to undergo a lot of repairs, maintenance, and all those costs. But in case of this particular cement, which is a very densely packed cohesive in nature, it will not generate, and at the same time cement generation, that carbon dioxide emission is very, very low, lower heat hydration, so it will produce a cement which will not generate cracks to the extent other prevalent cements are generating. So in which way there can be a lot of saving for the end user as well. Global scalability, so a lot of in the other countries it has caught the fancy, but in India it is almost a couple of players have started manufacturing it. But to the best of my understanding and knowledge in the cement industry, more and more players will come in this frame, and considering the long-term benefits, commercial viability, and gradually the acceptability which is being built up. So with this, I conclude this presentation. I hope I could meet the timeline. Kaushik sir?
Yes, sir. Yes, sir. Yes, sir. Very nice.
And yeah.
Nandakumar, can you pick up some questions which are raised? Nandakumar. Nandakumar, you are online? Nandakumar, are you online? Can you pick up some questions asked by the audience? And
Hello, sir. Am I audible, sir?
Yeah.
Hello.
yes.
Yeah, please.
Hello. Good evening, sir.
Yeah, you're audible.
Am I audible, sir?
Yeah, Mr. Nandakumar, you're audible, please.
Hello. Am I
Nandakumar, you
audible,
are
sir?
audible. Please ask the question to the speaker.
Yeah, please ask.
Hello. Good evening, sir.
Yeah, good evening.
Hello. Yes, sir. Am I audible, sir?
Yeah, you're audible. Please go ahead.
Yes, yes,
Is there
sir.
a
Yes, sir.
question?
Actually, some network issue, sir.
No issues, please.
Okay. Yes, sir. Actually, Mr. Patil, sir, asked one question.
Yeah, please go ahead.
Done on LC3 cements to against OPC, PPC, and PSC, sir.
Sorry, can you come again, sir? Please.
What are the carbonation studies done on LC3 cements against OPC, PPC, and PSC, sir?
Okay. As I mentioned in one of my slides, like we have to straight away compare all the three different types of cement with OPC, right? OPC is anyway the highest, CO2 generating cement, right? That we all understand. So we have taken a benchmarking against OPC, and when we talk of PPC and PSC, so these are the two types of cement which generate almost 25 to 40% of less CO2 emission in the atmosphere. Talking about LC3, which is a new invention, it also has the capacity of at least 40% less CO2 emission as compared to OPC. So it can very well be compared with slag cement and PPC, and almost at par as far as CO2 emission is concerned. But the biggest advantage with LC3 is that the fuel consumption which is required to manufacture is almost 50%, and at the same time clinker composition is almost 50% as compared to OPC. So these are the certain advantages that it makes it most appropriate in today's context. Yeah, Mr. Nandakumar. Yeah, Nandakumar, can I have I given you an answer? Yeah.
Yes, sir. Yes, sir. Yes, sir. Yes, sir. Thank you, sir. Actually, another question also asked by Christopher Matthew, sir.
Yeah. Okay.
Sir, he is asking that one side we are operating of lesser use of virgin materials like limestone. Another side we are trying to add limestone fines to the cement. How it eco-friendly, sir?
See, in case of if you are using limestone in any which way, all types of cement, you have limestone is the only raw material, as we know, right? Whether it is OPC, whether it is blended, or whether it is LC3. But in case of LC3, it is not pure limestone. As I have given you the figures, it is only 15%, 1.5. So, whereas in case of OPC, it is almost 90%. In case of PPC and PSC, it is almost 55 to 65%, right? In case of LC3, it is only 15.15. So it is significantly lower. So we are not only conserving this, limestone deposits also, because we know that limestone have a very limited shelf life. Possibly 100 or 150 years down the line, the limestone would definitely get exhausted from the globe. So, but 150 years down the line, construction will never stop. So what we need to do? We need to devise such technologies, such materials replacements, such options, or such different methods wherein we can conserve the basic raw material, that is limestone. So LC3 gives us an opportunity to reduce limestone content significantly from 90% or 65% or 55% to 15%. So that gives you a very fair idea as to we are saving humongously the quantum of limestone which is given, which is added to manufacture LC3. That's correct, right? So that is why it becomes a sustainable cement.
Thank you. Thank you for the answers. Actually, there are some other questions in chat box. Like Nagendran sir was asking that. Okay. Questions. Okay. What is the Vinay Mehta sir is asking that what is the IS code for LC3, sir?
Yes, but I'll just share it with you. I have it, but I'm just unable to recall it at this point in time. I will give you this. I will give the number. IS code. Yeah.
Yes, sir. Also, another one question, sir. One from Sakib Hagamat, sir, was asking that LC3 is globally used for construction, sir.
Yeah, it is being extensively used.
Okay, like some places.
Yeah, it's for all type of even for the structures of high grade concrete also. Yeah.
Okay, for normal and SDC.
Sorry.
For both normal concretes and SDC concretes, sir.
Yeah, for all means normal concrete for normal structures. Okay, and for as you're asking about the self-compacting concrete.
Okay.
For all type of applications. Yeah, and the BIS code is 18189.
18189.
Yeah, 18189 2023. That is almost 3 years ago. This particular cement has been given BIS code and approval for manufacturing.
Okay. Also, Nagendran sir asked one question. What is the fineness of LC3, sir?
Fineness is, as we understand, it is ground very, very fine. So, BIS code specifies its fineness about 300 meters square per kg, almost the same of PPC and slag cement.
Okay.
Yeah.
Thank you, sir. Another questions. Vinay Mehta sir asking another question. Are there any issues with achieving area strength development of L3C concrete, sir? LC3 concrete.
Sorry, can you come again?
Any issues of achieving early strength development of LC3 cement, sir? Any?
No. See, as I said, that its setting parameters are determined by the addition of gypsum. Okay, so it is basically a set retarder. So it does not have any adverse effect as compared to blended cement. I'm comparing it with the blended cement at this point in time as far as setting parameters are concerned. So it is almost as same as our blended cements. So no difference in setting parameters. IST and FST, that is initial set and final set, are close to similar to blended cements.
Yeah, I want to add one.
Yes, sir.
In the chat box, one of the question by Chandrasekhar Gupta, he asks, what is the maximum content of LC3 can be used in concrete per cubic meter?
Maximum content of LC3 per cubic meter.
Per cubic meter can be used.
Okay, as far as the concrete mix design is concerned, 10262 is the standard, code for all kinds of mix designs. So the quantum of cement required is similar to what other like OPC or PPC is added. So there's no difference, because as I mentioned specifically in my previous slides, that content and performance is not different from the existing cements. So it will, again, it's, as we know, concrete mix design is a subject of trial and error.
Okay.
So there's no code specification for a particular quantity. It has to be on the same parameters.
Perfect.
Thank you, sir.
Thank you.
Yeah, welcome.
So, another question from Sakib Bagamat, sir. How does the strength development of LC3 compared with OPC, sir?
See, as compared to OPC, it is definitely going to be a little less, but being a blended product, the later strengths will be significantly higher. Later strengths. So that is how it works, almost on the same parameters of the blenders.
So later it will increase or
it will increase. It will increase for sure.
Okay.
Because of very intergrinding processes among the calcined clay and the limestone, and obviously the clinker composition is always there, 50%. So they will, they will work with each other cohesively, and then the hydration process will start, and that is how gradually the strength will also emerge. It will be comparable to blended cements, but definitely slower than OPC. But later strengths means post 28 days. Post 28 days, or what we call a later strength, will be higher than OPC concrete. Yeah.
Sir.
Yes, sir.
Thank
you, sir.
I think time is too fast. I think we have to stop at one point of time, because the questions will be continuously coming. There is no, I mean to say, end for this. We'll have probably another session after 2-3 months probably.
Sure.
Sir, we are extremely thankful to you for your excellent presentation.
Thank you very much,
on
sir.
behalf of QCRETE Readymix India Private Limited and ICI Mangaluru, I am really honored to have you today, and it was a great lecture talking about the details of a new product, I can say, in the market. Of course, it is available elsewhere. In other countries, people have been talking about LC3 for a long time now, but in India, you have introduced through this webinar to many of us a new subject in the cement industry. We are extremely thankful to you, and I am really confident that the audience will appreciate the details given, especially these subjects which talk about eco-friendly concrete and eco-friendly cements are going to be the cornerstones of future. And I'm very happy to call you one of the architects of the future. Thank you. Thank you.
Thank you very much, sir. It's been a sheer privilege for me for being a guest speaker in this very, very reputed forum. Many thanks to management of QCRETE Readymix Concrete, especially to Kaushik sir, who has been very much a very, very old friend of mine, and all the dignitaries of QCRETE Readymix Concrete. At the same time, I am actually grateful to ICI Mangalore chapter, and looking forward to contribute more and more as and when I am being called for, and it's a really privilege. And thanks very much for the all the audience and all the participants who have joined us and took their time, valuable time in these evening hours. Generally, after a whole day's work, people have very limited attraction towards attending a technical seminar. At least, had it been some other interesting forum, possibly more number of persons would have joined. But still, a lot of good questions have come up, and I could contribute to some of them. And I request if all the questions that you already got, if it can be mailed to me, I'll reply to you appropriately on this.
We can.
Yeah.
And we are again from QCRETE, we are thankful to all the audience. We don't normally get big people in the industry like Dr. Nagendra, Nirmalendu, Kar Gupta, Sunit Gupta, Chandrasekhar Gupta, a lot of people. One Saurabh Singh is there, and who is known in North India. And we have Suresh Tripathi ji, a lot of people are there from across India. Thanks to all of you, and thanks to Anil Baliga sir for today's hosting. Thank you. Namaste.
Thank you very much, all of you, sir. And it's very a privilege for me. Thanks very much. Looking forward to meet you more often on such platforms. Yeah, thanks.
Thank you. Thank you. Thank you, Kanishk and QCRETE team for today's arrangements. Thank you. Thank you.
Okay, sir. So I just sign off. Thanks very much. Yeah.
Okay. Thanks again, once again. Okay.